So now our next speaker is gonna be Luke. He's gonna give you a virtual tour on BioSense. So Luke, can you share our screen?
Yep. Okay, so first I apologize. They are mowing the grass outside my window right now, so if there's some background noise, I'm sorry. But we're going to do this virtual tour of BioSands and part of the Cold Guide Hall at Heifer. And you can do this yourself. We have these virtual tours posted online. If you go up to neutrons.onl.gov at Heifer Virtual Tour, which is also found in this About menu, there are virtual tours listed here. We'll do another one later with Kevin for the labs at SNS. But that way you can go through this on your own, and there are actually some talking points in here that that you can click on, and some videos that go along with them that you are able to go through that I will not be going through today. So when you come to Heifer, you can see outside the window here, there's your user building. That's where you'll check in at Heifer, and then you come through this door, which is the main door to the Cold Guide Hall. Now, if we turn around, I'm sorry for any kind of motion sickness, but it'll be kind of like going through Google Maps. When you come in to your right, we have a sample management area. And at this area, there's a desk, and Chu or Kristen will be stationed here and help you check in your samples and sign off some safety documents, and get you started on your way to getting all of your samples prepared to run at BioSands. And then we also have back here our wonderful RCTs that are always on site and always there to help us with any kind of radiation hazards. Now from the sample management desk, if you turn directly to the left, CG3, that is the BioSands instrument. So this is where you would enter for our user area of the BioSands. But before we get to that, I'm going to go back towards the door here, and we have a staircase over here where I'll head up. Get here first. Head up the staircase and actually head over to the middle of this bridge, which we call a catwalk, and take a look over the top of the instruments here. So right now we're facing north in the building, and where we're looking at this big wall in the background, that separates the Cold Guide Hall from the beam room and the reactor itself. So beyond here is where the neutrons are produced. And then they're all go through a beam port, which we call the HB4, high beam 4 beam port that feeds all the neutrons into the Cold Guide Hall. From here, we have on the right side, this is our CG1, so CG stands for Cold Guide, CG1 beam line, so there's a guide that comes through here and feeds a couple instruments, mainly the alignment station and the imaging station. Next, CG2 is here in the middle. If you can't see my mouse, just let me know. I'll go a little bit slower, but I'm trying to make sure this circle shows up. So CG2, this is the GP SANS beamline, very similar to BioSands, but more for general purpose. Then CG3 comes the next one to the left, and that is the BioSands beamline. And finally, CG4, which is all the way to the left here, which has a few instruments on it, primarily the CTAX instrument, which is the triple axis, and a little further down, the Imagine instrument, which is a protein crystallography instrument, which some of you may be interested in using. So going back to BioSands, I'll step you through all the components here on the BioSands instrument. Under this white shielding up towards the north wall, there are these red lines that indicate where our guide are underneath, where the beam line is. So this red line follows the glass guide underneath that shielding, which is evacuated to make sure there's no interference from the air, and feeds the neutrons into into the BioSands instrument. Now, under this blue shielding is where our instrument controls begin. First, closest to the beam source, we have a velocity selector. This is kind of like a giant turbine that has shielding blades in it that define the wavelength of the neutrons coming into the instrument. And then just downstream from there, we have the smaller shielding block. This covers an attenuator, which is a shifting piece of poly that helps us control the intensity of the beam as we do different measurements. Typically for a user experiment, this is going to be completely open. So we can get the full flux out of that. So just behind that downstream, at the very end of this blue shielding, we have a beam monitor, which measures the flux out of what's coming in, I guess, out of the source coming into the instrument. So right there, we can measure our flux into the instrument to make sure everything coming in looks okay. Now downstream from that, we have these aluminum boxes. These are our collimator boxes. They are evacuated, and there are 8 of them that are each 2 meters long. Inside each box, we have a glass guide on one motor, and then an aperture on another motor. This first box actually has 2 apertures, 20 and 40 millimeter round apertures, and they can shift in and out of the beam. So the aperture, when we push the apertures into the beam, we are defining the beam at that location as that distance. And if we put the guide in the beam instead, we are allowing more neutrons to go through and controlling the, I guess, collimating the neutrons towards the instrument. So I'm just going to swing down here with follow those collimator boxes. You can see it goes on for quite a while there. So as I said, there's 8 of those boxes that are 2 meters long. They're all connected with one vacuum system. And then they go into this darker area here. That's our sample area, followed by the detector tank in the back here. So that is, you showed a little bit of that earlier, but I'm going to now, instead of walking you back down the stairs and around the building, I'm going to jump up to the mezzanine back here so we can get another look at the detector tank, and then I'll come back to the sample area. So this is at the very back of the building. You would have come up these stairs, and you can overlook the entire cold guide hall. And you can see here that we have both the SANS tanks. GP SANS is a little further away from where we're standing, and BioSANS is here closer to us. Excuse me. So the BioSANS tank is 15.5 meters long. Inside, as you had mentioned, we have what we call the main detector, and that is, sorry, my mouse is moving on its own. That is a large square detector that is helium-3 tubes and are sensitive to the neutrons, position sensitive detectors. This detector can move from the 15.5 meter mark at the back of the tank up to the 2 meter mark. And that will, excuse me. So that will define the Q range that you're looking at when you're measuring off your sample. So that as the samples scatter neutrons, the further away you get from the source there, from the sample, will give you a lower Q that you're measuring. Now, as was mentioned earlier as well, we have a wing detector towards the front of the tank. This rotates from 0 to 12 degrees in and out of the beam. And it helps extend the range from the main detector. So it's always measuring a higher Q range than the main detector, but it will either allow you to overlap some data a little bit better if you're doing multiple positions, or it can actually extend the Q range of a single position measurement so that you can actually, in some cases, collect a single Q range. So this whole tank is evacuated, usually to 10 to the minus 6 bar, and that way it allows us to not have the neutrons that are scattered off your sample interact with any air scatter as well that would cause background. Okay, so from this position, we can go downstairs and walk around this lab area and come back to the instrument. So I'm just going to jump down to that area now. And this puts us right back to in front of where I started with the sample check-in area to the left here, and then walking down towards the BioSANS instrument. So from here, as you walk up, the first thing you can see is our shutter control system. This is where we actually control the beam on and off into the instrument. We have key switches here that you'll be allowed to use the secondary shutter one when you're on site. And turning that on and off opens the beam to your sample. There are also indicators here on top. Green is beam off, red is beam on. So that, for us, that means red, don't go in, stop, and green, you're safe to go in. We also have indicators over the collimators for that, and there's also one above the tank as well that we can't see from this position. So when you are operating, you'll come in to the BioSANS instrument, and this desk here to the left is our user desk. There's an instrument computer here for you to have beam data analysis if you prefer to use the larger screens that we have, or you can also set up your own computer on this desk. We have electronics cabinets, which control all the motors and the detectors and the voltage on the detectors. And then in the back here, we have this other computer that you can see is on, and that is our control computer, where you will control all the motors that you're using, all the scans that you're running. Usually I believe Venki will be going through this, but we set up a panel scan or a sort of table scan script with you to run through all your measurements to automate most of our processes. So the last area we're going to go into is back here beyond this gate, which is typically posted as a radiation area. And when we enter this area, we have these countertops here where you can stage your samples. You can sometimes load samples in there. Typically, we want users to use the labs to load samples. It's just a much better area, more ergonomic and all the tools that you need are in the labs. But you can stage your samples here, and when you take them out of the beam, this is where we'll set them before the RCT gets a chance to look at them. And then we have some sample environments back here and in this cabinet, which I'll be talking about next in my next presentation. But when you walk in this area, the big thing to see is here's the end of the collimators that lead into our beam extender tube, which is also evacuated. And then that goes into our sample area, which is beyond this black frame. And what you can see in here now is our sample changing robot, which I'll talk a little bit about later. And then the sample position is right about where my mouse is pointing now. And as the neutrons come in through this beam extender tube, they scatter off the sample into the detector tank, where this area would be where the wing detector is, and then the main detector further back. So with that, this area is a high radiation area while we're running. So we have these laser scanners that are over the area so that you cannot reach in to the area while the beam is on without setting off an alarm. But this will be the general area that you'll be working in. When you're here, you'll come in, load your samples in this area, and come back over towards this desk to operate everything. So that's kind of a quick run through of what we have. If you go through this on your own, if I come back in here, you see these green dots around. This will give you highlights of things that we have done, or more information about the instrument if you want to see. But you can do that on your own. I won't go through those right now. The last thing I do want to go through is if we come back here and go towards the back of the building here. What we have is a couple of lab spaces, and I will let Chu tell you a little bit about these. This here is our general chemistry lab. So
Yeah. This is so in the Hive we have two labs for user to prepare their samples. One is the chemistry lab, and then we have another one beside of this room is the biology lab. So if you have the biohazard material, we will let you use the biology lab for sample preparation. But most of the time, if you just have the sample is not really biohazard, you will use the chemistry lab. For this lab, we have common equipment like water bath, centrifuge, pH meter, hot plates, nano drop for you to check the protein concentration. And also we have the glove box if you have a nano material you need to work on. So you can use the glove box there. And also, we have the lyophilizer. If you need to dry your sample, we have vacuum ovens, and all those the equipment is free for your use. And also, we have the general the lab supplies. I suggest if you want to come to the Hive have a beam time, you want to get sample preparation, you can let us know what type of the equipment or what type of the lab supplies you need for your sample preparation. We will so we get idea, and then we will let you know what you need to bring with you, and then we can supply to you. So that's the quick tour for the lab. When you come to the lab, when you come to the Hive to do experiment, we will give the specific training for the lab, because the lab is belong to the radioactive material area. So we have the special training for that. And also, the Luca mentioned we have the sample checking area. So I suggest when you come to the Hive to the experiment, the first stop, go to the sample checking area, so you can, because for the sample checking is not only for sample checking, we also do the sample shipping. So if you send your sample to us, we will receive your sample here, and based on the requirement, we will store them. And then you come here, we will let you where's your sample. And then before you run experiment, all the sample have to be checked in into our the item system. So that's I suggest. And but I think all those detail we can talk about when you get your beam time, you come to here. Yeah, thank you.
Yeah, thank you, Shu. One thing I did want to add also about the lab is you may have saw we do have some refrigeration storage there for your samples if you need to keep them cold before you run, or if you need to ship them ahead of time, we can store them for you. Are there any questions?